All right, welcome to week 2 of our geometry class. Week 1, we did some thinking about social distancing in the poster. In week 2, the video piece of this is going to get into this heart of algebra idea. So we're going to focus on solving one-step equations and inequalities and graphing the solution of an inequality on a number line. So, couple of helpful hints with videos and learning. Pause them. Try the problem. Watch the video to check your answer. I highly suggest interacting with the video. I know it's a little strange that you're just watching a video, but if all you do is just sit and watch the 10-20 minute video, but you don't interact with it at all, it's going to make the learning process a little bit harder. Now, the content that we're going over in this video is definitely a review of Algebra 1, so it shouldn't be a challenge for you to actually do the math, but you may need a bit of a refresher on it. So interact with the videos. It's going to be really helpful in your learning process to actually interact with those videos. So, starting this out, I will be passing out to you guys this week workbooks, and I will reference pages in the workbooks that will be useful for practice with the math that we're actually doing. So let's go ahead and let's dive right into our examples. So step 1, or learning target number 1, is I can solve one-step equations. Hopefully you guys remember this. We are looking for the opposite operation. So the opposite of subtraction would be, yep, you got it, addition. The opposite of addition would be subtraction. Opposite of multiplication is division, and the opposite of division is multiplication. Now, a lot of times we're not going to see division using a division bar. We're going to see it using a fraction bar. And remember, a fraction bar is just another way to write a division symbol. So let's go ahead and tackle example 1 and example 2. You may have seen your previous Algebra 1 teachers do this. I sometimes like to draw a line to denote one side of the equation to the other, because whatever I do to one side of the equation, I have to do to the other side. I also sometimes like to highlight the variable that I'm solving for. And you're probably going, wow, PK, this one's really easy. I can do this one in my head, and that's fine, but I'm showing you these basic steps on example 1 and 2 because as we move into additional examples. So the opposite of this negative 20 is going to be positive 20. So I'm going to add 20 to both sides. I draw my equal sign like I did in elementary school. These two equal to what number? Not 1, but 0, yes. So that means I'm going to drop my variable. And then negative 32, if I go 32 steps backwards and then 20 steps forwards, I'm still at negative 12. Now, how can I verify my answer? I can check it. I can do negative 20, which is my original problem, plus a being negative 12. And I'm going to do that math. Negative 20 and negative 12 is negative 32. And negative 32 does equal negative 32. So it checks out okay. All right, second problem. Example number 2, 180 equals negative 18x. What does it mean when the 18 and the x are connected and there's no symbol? You are correct. If there's no symbol, it means to multiply. And we know the opposite of multiplication is division, so I'm going to draw my line down. I'm going to divide both sides by negative 18. My negative 18 and negative 18 cancel. They divide out to positive 1, which leaves me x. 180 divided by negative 18 is negative 10. So again, we can check our work. Negative 18 times negative 10 is negative times negative is a positive. 18 times 10 is positive 180, and it checks out okay. All right, 2 more one-step problems. All right, how do I read number 3? Example number 3 says 11 equals r over 5. And over is the word that a lot of you guys use. I like to use the word divided by, because fractions are just another way to write division. So once I know it's just another way to write division, what's the opposite of dividing by 5? You're right, times by 5. So I'm going to use my dot for my times. My 5's divide out. I'm left with r. 5 times 11 is 55. Okay? Example 4. Now, I am still solving for k, but k actually happens to be negative. So we're going to do a little switcheroo. I'm actually going to move k first. It's really not a one-step problem. It's going to be a two-step problem. So those two k's cancel, and I'm left with k minus 7 equals positive 9. Now, when I actually solve this, I'm going to add 7 to both sides. So k is equal to 16. Again, we want to isolate the variable. We want to isolate it as a positive variable and go from there. So hopefully you guys didn't have any problems with those first 4 examples. Let's get into maybe a couple more challenging ones. Two-step problems. So if I read example 5, because I always like to start reading it, it says x plus 9 divided by 21 is equal to 1. So that says the whole x plus 9 is divided by. How do I know the whole x plus 9 is divided by 21? Because the whole thing is on the top of the fraction. Okay? The whole thing is on the top of the fraction. So I like to undo my division. First, what's the opposite of multiplying by 21 or dividing by 21? You got it. Multiplying by 21. This 21 divides that 21 out. We're left with x plus 9 is equal to 21. Now it's a pretty simple problem. We're going to subtract 9 from both sides. X is equal to 12. Okay? Now, example 6, negative 14 equals 2 times the quantity, because it's in parentheses, of n plus 7. So I'm going to actually do this one maybe a little different than you've seen in the past. Most of you may say, well, PK, can't we just do this? And we could multiply both of them. But I'm going to actually say 2 times a quantity means that I can divide the entire thing by 2. And these two 2's are going to divide out. So that leaves me negative 7 equals n plus 7. Last but not least, we're going to subtract 7 from both sides. N is equal to negative 14. Okay, so there's your two-step problems. Multi-step. They get just maybe a little more complicated. Nothing major. This is where we're going to do one that actually has that distribution. So I'm going to distribute my 4, and I'm going to multiply inside. So I'm going to get 4 times 1 is 4, minus 4 times 5 is 20, minus 2m equals negative 84. Now, again, I like to highlight this negative 20m and this negative 2m are like, they're both red M&Ms. So I can put all the red M&Ms together. So I'm going to do that. My 4 does not change. These two things became negative 22m, and it equals negative 84. Now I'm going to subtract my 4 from both sides. Negative 22m equals negative 88. Divide by negative 22. M is equal to 4. Now, again, I would highly suggest pausing. Pause. Do number 8 in your notes. Then watch the video to verify your accuracy in solving this. All right, I'm going to distribute 6n plus 30 equals 6n plus 30. Oh, the left side and the right side are equal to each other. Huh. Subtract 30. Because we can move things around. 6n equals 6n plus 0. Those cancel too. Okay. I'm going to subtract 6n from both sides. That's a 0. That's a 0. 0 equals 0. I didn't get the variable by itself. I got something funky. So we're going to put an asterisk next to this one and talk on the next slide. There are these special cases when we solve equations. If you get 0 is equal to 0, you get 4 is equal to 4, you get 5 is equal to 5. If you get anything that's equal to itself, this is called an identity. And an identity means that the equation is true for all values of the variable. So just a note with those. Now, where can you go for some extra practice? Extra practice is going to be pages 4 through 6 of your workbook. You can use those pages as extra practice, and hopefully those will help you as well. All right, so let's get into solving inequalities. The cool thing about solving inequalities is it's the same as solving an equation. So I'm going to drop down my line. I'm going to subtract 2 from both sides, just like I would do in an equation. Negative 3x greater than or equal to 4. All right, I'm going to divide by negative 3. X is greater than or equal to negative 4/3. Now, I'm just going to leave it at that. But I am going to check my answer. Okay? So, and I'm going to leave the fraction. Because if I think about a number line, 0 is here, negative 1 is here, negative 2 is here. Negative 4/3 is like right there. Because that's the same as negative 1 1/3. Okay? So on the other side, I'm going to have 1 and I'm going to have 2. So read the inequality. This inequality says x, the missing number, has to be bigger than or equal to this negative 4/3. So when I look at negative 4/3, which side of the line or which side of negative 4/3 is bigger than negative 4/3? If you said anything on this side, you would be correct. And it continues. So give me a number that's bigger than, or pick a number that's bigger than negative 4/3. I'm going to try x is equal to 0. Are you okay with that? Is x equals 0 bigger than 4/3? Yes, this is greater than or equal to negative 4/3. All right, so I'm going to substitute in. Negative 3 times 0 plus 2 greater than or equal to 6. Well, this is 0 plus 2 greater than or equal to 6. 2 greater than or equal to 6. Wait a second. 2 is not greater than or equal to 6, is it? Oh, yes. I heard somebody shout it out in my brain. And the issue is our sign. Our sign shouldn't be greater than. Our sign needs to read x is less than or equal to negative 4/3. Now let's try another one of those. Let's try negative 2, because negative 2 actually is less than. So x equals negative 2, which is less than or equal to negative 4/3. All right. Negative 3 times negative 2 plus 2. This gives me 6 plus 2. 6 plus 2 is, yep, you got it, 8. Is 8 bigger than or equal to 6? Yes, this one checks out. So, the issue is this negative that we divided by. See, we divided both sides by negative 3. By dividing by sides by -3, we need to reverse the inequality sign. Okay? So everything else is the same when we solve an inequality, except for the fact that when we divide or multiply by a negative number on both sides of the inequality, we have to switch the inequality sign. All right, so summary-wise, if you multiply or divide both sides of the inequality by a negative number, and I'm actually going to change this by a negative number to by the same negative number, then you reverse the inequality symbol. So, let's say x over -2 greater than 5. When we solve it by multiplying both sides by -2, we say x is not greater than -10. We say it needs to be less than -10. So notice the signs flip. Okay? All right, graphing. All right, let's graph x is greater than 2. So, we're going to locate the 2 on our graph, on our number line, and we're going to say which numbers are greater than 2. Great, I heard you guys shout out 3, 4, 5, 6, 7, 8, 9, 10, and actually any number bigger than 2. Is 2 bigger than 2? You're right, again, 2 is not bigger than 2. So that means 2 is not part of the solution. So I put a nice big open circle on 2, and I shade my line to the left, or to the right. Helps if I know my right and my left today, sorry. So, let's try another one. Let's say x is less than or equal to -3. So that means -4, -5, -6, -7, and so on. They're all there. So that means I'm going to say, is -3 less than or equal to -3? The answer is yes. So that means instead of using an open circle, I use a closed circle, and I shade, this time, truly to the left. So that means when I have greater than or equal to, or less than or equal to, I used a closed dot as my boundary. Okay? If I have greater than or less than, I use an open circle as my boundary. And then I shade whichever direction I'm looking at. We're going to stop there. So, problems. Where can you find extra problems for this? I would say extra problems on this one, and I'll actually write this in your show notes. I feel like I'm doing a podcast. I listen to podcasts all the time too. Pages 7 through 10, and I'll provide some show notes for you for this video. All right. Happy talking to you. Give these problems a try. After you watch the video and you give these problems a try, go ahead and do the Schoology assessment. Hopefully you can earn that 10 out of 10.